Welcome to Implicit Differentiation. The goals of this video are to differentiate implicitly and also to find the slope of a tangent line at a given point. Explicit equations or functions are those that are solved for y. We say the variable y is explicitly written as a function of x when it is solved for y as we see here. Implicit equations or functions are those that are not solved for y. As a result, we must use implicit differentiation if we want to find dy dx. An example of an implicit equation would look like this. And you can imagine if you tried to solve this for y, it would be very challenging. Now, to understand how to find dy dx of an implicit equation, we must realize we are taking the derivative with respect to x. As a result, if the term only involves x, we will take the derivative as usual. However, if the term involves y, we must apply the chain rule because we assume that y is a function of x, or y is defined implicitly as a differentiable function of x. So let's take a look at how we are going to differentiate implicitly. First, we will differentiate both sides of the equation with respect to x, or possibly some other variable. Then we will apply the rules of differentiation as necessary. Anytime an expression involving y is differentiated, dy dx will be a factor in the result because of the chain rule. Next, we'll isolate all terms with dy dx as a factor on one side of the equation. Then we'll factor out the dy dx, and then we'll divide on both sides of the equation to isolate or solve for dy dx. Let's go ahead and give it a try. Let's find dy dx, then find the slope of the tangent line at the given point. Okay, so step one is to differentiate both sides of the equation with respect to x. So if the term involves x, we'll differentiate as we normally do. So the derivative of this term would be 4x minus, now this term involves y, so we'll differentiate this and then have a factor of dy dx. So this would be minus 9y squared times dy dx. And again, we're just thinking of y as some function of x, and we're applying the chain rule. Equals 0. So we'll isolate this term on one side, so we'll subtract 4x on both sides. And then we'll divide by negative 9y squared. These simplify. So dy dx is equal to 4x over 9y squared. So that's implicit differentiation. Now the second part of this question asks us to find the slope of the tangent line at the point negative 2, 1. So now we're going to take the derivative function and evaluate it at the point negative 2, 1. So x is negative 2 and y is positive 1. So we'll have 4 times x, or 4 times negative 2, over 9 times y squared, or 9 times 1 squared, which will give us negative 8/9. The slope of the tangent line at the point negative 2, 1 should be negative 8/9. Let's go ahead and take a look at the graph to verify this. One thing we'll notice is when we graph implicit equations, we often get very interesting graphs. Here's our point of tangency, negative 2, 1, and we can see a slope. Well, the slope was negative 8/9, which is almost negative 1, and we can see the slope does look very close to negative 1. Let's try one more. First step, we need to find dy dx. So we need to find the derivative with respect to x on both sides. So when we go to find the derivative of y cubed, we have to apply the chain rule. So we would have 3y squared times dy dx. Sometimes you'll see some textbooks writing y prime. I don't like doing that because it looks too much like y to the first power. Now plus, this is actually a product of two functions. We have to apply the product rule. The first function is x squared, and the second function is y to the fifth. So we'd have x squared times the derivative of y to the fifth. Again, we have to apply the chain rule when we differentiate y to the fifth, so we'd have 5y to the fourth times dy dx plus the second function, y to the fifth, times the derivative of x squared, which would be 2x, minus the derivative of x to the fourth, 4x to the third, and then the derivative of a constant, of course, is 0. Now this next step, we're going to keep the dy dx terms on the left side, and we'll move the terms that don't have dy dx in them to the right side. So when I rewrite the left side, I'm going to factor out the dy dx at the same time. So I'd have 3y squared plus, I'll rewrite this as 5x squared y to the fourth. So these are the terms that had dy dx in them. And since I'll be moving these terms to the right side of the equation, I'd have a positive 4x cubed, and then I'd have a minus 2x y to the fifth. Since these are connected by multiplication, the last step will be to divide by 3y squared plus 5x squared y to the fourth on both sides. So now we simplify and we have our derivative. Okay, the second part of this question asks us to find the slope of the tangent line at the point 0, 3. So we need to evaluate this derivative when x is 0 and y is 3. Now we may think that's going to be a lot of work, but since x is 0, if we take a look at this numerator, we'd have 4 times 0 cubed, that's 0, minus 2 times 0 times y to the fifth, that's also going to be 0. So our numerator would be 0. In our denominator, we'd have 3 times 3 squared plus 5 times 0 squared times 3 to the fourth, of course, is 0. So the value of the derivative at the point 0, 3 is equal to 0. Again, let's go ahead and look at a graph to verify this. Here we have our function, here's our point of tangency, and we can easily see that at that point, the slope of the tangent line is 0. Again, this verifies our work. I hope that helped explain how to differentiate implicitly. Thank you for watching.